Okay, guys. Lesson 1.5, day 2. I asked you to pick up where we left off yesterday. And that was to finish part C. We looked at A, we looked at B, never true, always true. Part C. What did you guys start off doing?
Distributing the 4 and 6.
Okay, start with that distributive property again. So, as we distribute, on the left, this is going to read what?
4x minus 12. Or 8x minus 12.
I like that one better. 8x minus 12, less than. On the right, it's going to read
6x plus 6.
6x plus 6. Now, if you're someone, you're going to argue, I know the answer right now. Can I go ahead and put it down? I'm going to say yeah. Okay, because I can look at this and I know, in terms of is this going to be always, never, sometimes true, I know the answer at this point. Okay, so keep that in mind. Well, let me ask this. How would you know, how would I say I might know the answer right now? How can I say if I know this is always, sometimes, or never true? You want to keep going then?
Because
I have 8x and 6x. Are my x's going to cancel? No. Okay, so if you want to stop right there and say, okay, I know there's still going to be an x, it's going to be sometimes true, you could do that. Okay, if you want to keep going, what's the step to keep going?
Combine your like terms.
Yeah, so we want to move all of our x's to the left. If it's positive 6x, you subtract 6x. And I have 2x minus 12 is less than 6. Again, right here, is there going to be an x left?
Mm-hmm.
There's going to be an x left. I know it right here. If you're still not convinced, keep going. If it's 2x minus 12, I'm going to add 12. So then 2x is less than 18. There's going to be an x left, isn't there? Mm-hmm. And so since there's going to be an x left, I know that this is sometimes true. It is sometimes true. It is true whenever x is less than 9. So if x is 8, it's true. If x is 10, it's not true. Okay. Are we okay with those? Probably we're okay with those even without me doing that example. But the big thing I want to spend time on today are compound inequalities. So when you have two inequalities together in one problem, okay, they can either be connected by the word and, or they can be connected by the word or. Depending on which word they're connected by, makes a difference as to how the problem works, whether it is an and or an or statement. So you'll notice right there, there's some information. And inequalities are the intersection of two inequalities, and it's where the two graphs would cross, or I like to use the word overlap. And I'll show you an example and make it make sense, but with an and inequality, your graphs end up going the opposite ways, and there's a section in the middle that overlaps. And that's where your solution is. So it's the intersection of the two inequalities. With an or statement, it is what we call the union of two inequalities. And all numbers that, with an or statement, it's this or this. So all numbers are included. And with an or statement, you usually end up with your graphs going out and away from each other. And so nothing, it's not that nothing overlaps, but it's an or statement. So it's this or it's this. With an and statement, they go towards each other, and it's what overlaps in the middle. Okay, so those are the traditional and and ors. You would have seen this in Algebra 1, right?
Yeah.
How well you remember it's in a whole different story, right? I'm not assuming you remember it. I rarely assume that you automatically remember something from Algebra 1. I hope there's some bits and pieces there, but I never just assume, oh, yep, you guys got this, I don't need to teach it. So, now, good news is the solving is still solving. We don't have to do anything fancy there. So as we look at example 5 to get us started, what is the solution of 7 less than 3x plus 1 and 3x less than or equal to 18? Graph the solution. You see two inequalities. Now note they are connected by the word and. That is important to realize. But you're just going to take these two inequalities and we're going to solve them. If it's 7 less than 3x plus 1, how do I solve that?
Subtract 1 from both sides.
If we're trying to get x by itself, I can zoom in on this a little bit if that would be helpful to you guys. So to get x by itself, if it's 3x plus 1, I'm going to subtract 1. We subtract 1 on the right, subtract 1 on the left. 7 minus 1 is 6, less than 3x. How do I continue to get x by itself? If it's 3 times x, we're going to divide by 3. Now, 6 divided by 3 is 2, less than x. And traditionally, normally, what are you guys probably going to do?
Flip everything.
You're probably going to flip it and call it x greater than 2. What was the word in between? And. Okay. We have a second one to solve. 3x less than or equal to 18.
Divide by 3.
Good news is this one's easy to solve, isn't it? If it's 3 times x, just a basic divide by 3. And if I go ahead and bring that answer down, x is less than or equal to 6. Now, we have an answer here, yes?
Yeah.
And that is one way to write the answer. You must have the word and in there, though. But here's what I'm going to tell you. I forgot to check MathXL this morning. My guess is MathXL is going to want it as a compound inequality, though. And so this with and statements. It doesn't work with or statements. But with an and statement, we can write this where it's combined. Okay? And so what I mean by that is that we can write it as one big inequality where you put x in the middle and you put the numbers on either sides and the signs in there with it. So when we put the numbers on either side, easiest way to do this, best way to do this is to put your larger number on the right, which my larger answer number is 6, smaller number on the left. And then put the appropriate signs. Now, x less than or equal to 6, x less than or equal to 6. This was x greater than 2, but what was it when it was 2 and then x? That is 2 less than x.
Yeah.
Did I say that wrong a moment ago? I don't know.
X greater than 2.
Okay, that's what I meant to say. So the idea, this is going to be the best way to express your answer here. Okay? And this is probably what MathXL is going to be looking for. Only works with and statements. You heard that, me say that, right? You want to put your x in the middle. Best way to do this is smaller number on the left, larger number on the right. If you have an and, traditional and statement, smaller number on the left, larger number on the right, then both of your signs will be less than signs. And I will say both of those signs should end up pointing the same way if done correctly. Okay? Now that also kind of gives me an idea of what my graph is going to look like. Because it did ask us to graph this. So, let's graph it. What kind of numbers do I need on this number line?
Positives.
Positives? And I've got to have 2 and 6, right?
Yes.
There's some numbers in between. Maybe some numbers on either side. honestly, I'm going to count by twos on this one, I think. I'm going to say 0, 2, 4, 6, 8. I'm not saying you have to count by twos, but that's what I'm doing here. Now look at these individually. Okay? My recommendation is we look here first. What does x greater than 2 tell you? We're going to the right.
From 2.
From 2. And I'm just going to do some pencil for a moment.
It's an open circle.
And it's an open circle. Yes?
Yes.
This is just kind of me. This is our planning process, so to speak. So it's x greater than 2. Looking here, so we shade to the right. If you want to look here, you have to reverse this. X greater than 2. Now, what do we know about the 6th one? X
is less than or equal to 2, so it'd be a closed circle at 6 going to the left.
Okay, less than or equal to 6. Closed circle this time. And this time it's going to the left. Now, this is what I called an AND statement, correct?
Yeah.
So an AND statement, it's an intersection, and it's AND. It's where they both are true. Where the first inequality and the second inequality are true. Where are they both true? In other words, where do they overlap? Okay. Or in other words, what I'm going to say is they overlap between 2 and 6. Because notice how I did. This is why I kind of did this, to show they're overlapping there. So we already have our circles. Open circle at 2. Closed circle at 6. And then my shading is going to be between 2 and 6. Because you're only shading where they overlap. And they overlap between 2 and 6. Okay? What I put up above in that real light pencil, you don't have to have that on there. That was just me kind of showing it. Okay? All you have to have is what I ended up shading here in pink. Now, if you think about it, does this make sense with this? Because this is saying that x is between what? 2 and 6. Where did I shade? Between 2 and 6.
Yes, because 4 is greater than 2, but less than or equal to 6.
Yeah. Okay, questions there? This is one of those things you would be maybe less likely to remember from Algebra 1, just because it was probably brand new in Algebra 1, so. Okay, should we try another one then?
Sure, why not?
I mean, not that I'm really going to give you a choice, I guess. And I'm not saying we have to do all of these examples here, but I need to go through several examples to make sure we're on the right track. Okay, so second example. What is the solution? 7 plus k greater than or equal to 6, or 8 plus k less than 3. Did you catch that word?
Or.
It matters what the word is, guys. Okay? Now, because it's an or statement, there's a couple of differences about how we can handle this problem. But, what's the same? Solve them. Okay? No tricks there. Solve. If it's 7 plus k less than or equal to 6, how do I get k by itself? Subtract 7. So if I subtract 7, I get k is
greater than or equal to negative 1.
Greater than or equal to negative 1. Okay. What's the word I'm going to put in between these answers?
Or.
Or. You want full credit when you get to a test for me, you must write that word in there. Okay? The word or has to be written in or I'm not going to give you full credit. Just saying. Okay, solve the other one. If it's 8 plus k less than 31.
Subtract 8
Excuse
to
me.
both sides.
Less than 3. Gosh, that's horrible reading. 8 plus k less than 3. We're still going to
Subtract 8.
subtract 8.
K is less than negative 5.
K is less than negative 5. Okay, guys. That right there is your answer. And that is how you must express your answer. Okay? It's an or statement. You cannot combine it like we do the and statements. And statements, I expect you to combine. Or statements, it's this or this. We don't combine them. We just put the word or in between them. So this is how the answer would read. Okay? And we're going to have to graph it. Now, difference with the graph. Last time it was an and. It was this and this. So we had to shade only where it overlapped. This time it's either or, which means we're going to just shade whatever it tells us to shade. Let's see. I'm going to put 0, -1, -2, -3, -4, -5, -6 on my number line. K greater than or equal to -1.
Are we going to close circle at -1 and go to the right?
Close circle, -1, go to the right. K less than -5. Open circle at -5, going to the left. It's this or this. It can be either or. So you just shade it. You don't have to worry about overlapping. You just shade it. A traditional or statement is going to shade out. Traditional and statement is going to be in the middle. Notice I'm using the word traditional. Are there random weird exceptions? Of course. Of course there's random weird exceptions, but this is the basics. Okay. At least one more example, minimum. I might let you off the hook with the last two and give you work time instead. So, but I really want to do this next one because what type of statement is it?
And.
An and statement. And I feel like and statements are trickier. Maybe that's just me, but okay, solve away. 5 less than or equal to 3x minus 1. How do I get x by itself? It's 3x minus 1. We're going to add 1. 5 plus 1 is 6. Less than or equal to 3x. To get x by itself, we're going to divide by the 3. 6 divided by 3 is 2. Less than or equal to x.
I kind of find this one funny.
For graphing purposes, I encourage you to maybe flip that just to make sure you get your graph going correctly. So since it says 2 less than or equal to x, I'm going to flip it and say greater than or equal to 2. Carrying down what word? And. 2x less than 12.
Divide by 2.
Divide by 2.
X is less than 6.
X is less than 6.
Did you do this one on purpose?
No. Is this the best way to leave my answer, or should I rewrite my answer?
Rewrite it.
Because it's an and statement, you should rewrite it. What do I put in the middle?
Your variable.
X in the middle. What number goes on right? 6 because it's bigger. What number on the left? 2 because it's smaller. Between x and 6, it says less than. Less than sign. What about between the 2 and x? It's another less than. It started off as x greater than or equal to 2, but this is flipped. So less than or equal to. There is your ideal solution. Okay? What do you expect your graph to look like?
Circles,
Out or in?
Circles connecting each other.
Okay, circles connecting each other in, that's what you expect. Always double check. So, x less than 6, open circle at 6,
Circle going to the left.
going left. I'm only going to go so far left because I have to figure out how far left. X greater than or equal to 2 is what it was, so
Close circle at 2, going to the right.
close circle going to the right. Not horribly difficult, but they're definitely a little bit more than just your basic inequalities. Okay, I'm not going to solve the last two, but I want to ask a question. On this next statement, so example 4, we're not doing it, but what type of statement is that? What type of inequality?
Or.
It is an OR. So, without me doing any work, what would you expect a graph to look like for OR?
Going out.
Going out, yes? Okay, so we're going to expect, if we were to do this, our graph would go out, wouldn't it?
Yes.
Okay. This one is also
Or.
an OR statement, so you would expect the same thing, wouldn't you?
Yeah.
Okay. Your homework is in lesson 1.5. Some of you started last night. Some of you haven't done, actually. Okay. Get working on it. Okay. I expect you to see you working on Math Excel unless you have 100%. Due tomorrow, which is Friday.